Your container security scans are missing 98% of the actual vulnerabilities, and they're hiding in places you'd never check.
Wait, 98%? Where are all these CVEs hiding if not in the main images? So we're breaking down where these vulnerabilities actually live, why everyone misses them, and what Chainguard discovered.
By minute 4, you'll know exactly which containers to audit first. Let's get into it.
Welcome to the Platform Engineering Playbook Daily Podcast. Today's news and a deep dive to help you stay ahead in platform engineering.
Today we're diving into Chainguard finds 98% of container CVEs lurking outside the top 20 images.
Stick around to the end for this week's headlines. Let's dive right in.
So let's talk about this bombshell finding from Chainguard. 98% of container vulnerabilities are lurking outside the top 20 most commonly used images. That's a staggering number that completely flips the script on how most organizations approach container security.
Wait, hold on. You're telling me that while everyone's obsessing over securing Nginx, Alpine, and Ubuntu-based images, the real danger is hiding in what exactly?
That's exactly the right question. Think about your typical enterprise container registry. You've got maybe 20, 30 images that everyone knows about, your standard base images, popular application frameworks, common databases. Security teams audit these religiously. They get patched quickly, scanned constantly, monitored extensively. But then you've got this massive long tail of specialized images, obscure dependencies. That one Python library someone pulled in 3 years ago that's nested 5 layers deep in your dependency tree.
Oh man, I'm already thinking about that custom image we built for our legacy data processing pipeline. The one with like 47 different Python packages that nobody really understands anymore.
Exactly. And here's where it gets really interesting. Chainguard analyzed over 1,800 container image projects and found 10,100 vulnerability instances between September and November 2025. The concentration of vulnerabilities in these lesser-known images is mind-blowing. We're talking about images that might only be used by a handful of organizations, maintained by 1 or 2 volunteers if they're maintained at all.
But surely the popular images have more vulnerabilities just by virtue of having more code and more scrutiny.
You'd think so, but that's actually the paradox here. Popular images get so much attention that vulnerabilities are found and fixed quickly. It's like the difference between a busy highway that's constantly maintained versus a rural road that nobody thinks about until it causes an accident. The popular images have entire security teams dedicated to them. Alpine Linux, for example, has a rapid response team that patches CVEs within days. But that random node.js image someone created in 2019 with 200 downloads, good luck.
So what kinds of vulnerabilities are we talking about here? Are these theoretical risks or actual exploitable issues?
From what Chainguard's report indicates, these are real, exploitable vulnerabilities. We're seeing everything from unpatched SSL libraries to outdated compression algorithms with known buffer overflow exploits. The scary part is that many of these vulnerabilities have been public for years. They just haven't been patched because nobody's maintaining these images.
This reminds me of that supply chain attack we saw with, what was it, the event stream NPM package?
Yes, perfect example. A maintainer handed over control of a package with millions of weekly downloads to a malicious actor. But imagine that scenario playing out across thousands of container images that nobody's even watching. Coming up, we'll dig into exactly how organizations can start addressing this massive blind spot in their security posture, and why the traditional approaches to container security are fundamentally broken when it comes to this long tail problem. All right, so let's dive deep into why this long tail problem is so challenging. The traditional approach to container security has been what I call the celebrity image strategy. You focus your security efforts on the images everyone uses. Makes sense on the surface, right?
Sure, if 80% of your containers are running on top of Alpine or Ubuntu, that's where you'd naturally focus your scanning and patching efforts.
But here's the thing. Chainguard's data shows that while those top 20 images might represent 80% of container instances, they only account for 2% of the vulnerabilities. The math just doesn't work out anymore. Let me paint you a picture of what's actually happening in production environments. You've got your main application running on a well-maintained base image, fully patched, scanned daily. But then it pulls in a sidecar container for logging that hasn't been updated since 2020. That logging container has dependencies on an old version of OpenSSL with 3 critical CVEs.
How deep does this dependency rabbit hole go?
Oh, it's wild. I've seen container images with dependency trees going 15 levels deep. Each level multiplies your attack surface. And here's the kicker. Most vulnerability scanners only look at the direct dependencies. They'll catch that your base image needs a patch, but they miss that obscure JSON parsing library buried in a utility container that has a remote code execution vulnerability.
But surely modern scanning tools can traverse the entire dependency tree.
It's more common than you think. Step 2 is implementing what I call image genealogy tracking. For every image in production, you need to know its complete lineage: base image, all layers, when it was built, by whom, and most importantly, when it was last updated. If an image hasn't been rebuilt in 6 months, it's almost certainly vulnerable.
But rebuilding images constantly seems like it could introduce instability.
You're absolutely right, which is why step 3 is establishing a risk-based rebuild strategy. Not every image needs weekly rebuilds. Create tiers based on exposure and criticality. Internet-facing services running on obscure base images? Those need aggressive rebuild cycles. Internal tooling on well-maintained bases? Maybe monthly is fine. The key is having the data to make these decisions.
What about the developer experience angle? How do we implement this without becoming the security team everyone hates?
Such a critical point. The successful organizations are treating this as a platform feature, not a security mandate. They're building golden image catalogs with pre-secured, pre-scanned base images that are actually easier to use than random Docker Hub images. Include common tools, good documentation, automated updates. Make the secure path the path of least resistance.
Like an internal marketplace of approved images.
Exactly. And here's where it gets interesting. Some teams are going further and building image inheritance tracking. So when a base image gets updated, all child images automatically get rebuild triggers. It's like dependency management, but for containers. The tooling is still emerging, but projects like Flux and Argo are adding features to support this.
This sounds like a lot of infrastructure to build and maintain.
It is, which is why my final recommendation might be controversial. Consider whether you actually need all these images. The most secure container is the one that doesn't exist. I've seen organizations cut their image count by 70% just by asking, why does this need its own custom image? Often the answer is, because that's how we've always done it.
So consolidation is really the ultimate solution.
For many organizations, yes. But here's the nuanced take. Consolidation works great for stateless microservices. It's harder for legacy applications with complex dependencies. So you need a two-pronged approach: aggressive consolidation for new services and careful risk management for the legacy stuff you can't easily change.
What should teams be watching for as this space evolves?
3 big trends. First, we're going to see regulation catch up. SBOM requirements are already hitting government contractors, and it's spreading to other industries. Second, AI-powered vulnerability detection is getting scary good at finding issues in obscure dependencies. And third, we're seeing a shift toward runtime security versus just scan time security. Because let's be honest, you're never going to catch everything before deployment.
That runtime angle is fascinating, like observing actual behavior versus theoretical vulnerabilities.
Precisely. And here's my closing thought that might blow some minds. Maybe we've been thinking about this problem backwards. Instead of trying to secure thousands of images, what if we fundamentally rethought how we package and deploy applications? The next generation of platform engineering might not use containers as we know them today. WebAssembly, unikernels, even back to bare metal with better isolation. The 98% vulnerability problem might just be a symptom of container image bloat that we've all accepted as normal.
Wow, so fixing the long tail might require rethinking the entire model.
That's exactly right. The most important takeaway from Chainguard's research isn't just that we have a vulnerability problem, it's that our current approach to containerization might be fundamentally unsustainable from a security perspective. Platform engineers who recognize this shift early and start planning for what comes next will have a massive advantage. Before we wrap up, let's catch up on this week's infrastructure news. There's a fascinating new development in the Linux world that caught my eye. Laya Linux, an Arch-based distribution, is challenging the notion that high-performance Linux requires command-line expertise. According to the new stack, they're creating a completely point-and-click experience.
Wait, an Arch-based distro that's user-friendly? That's like saying you've made a friendly version of Vim. How are they pulling this off?
They've essentially wrapped Arch's power in an interface that feels more like what everyday users expect. The goal is making Linux accessible to a wider audience without sacrificing performance. It's particularly interesting for platform teams who need to support developers who aren't Linux experts.
That could be huge for adoption. I've seen so many talented developers shy away from Linux-based tools just because of the learning curve. If Laya can deliver on this promise, it might change how we think about developer workstations.
Speaking of major developments, AWS just landed a massive $581 million sole source contract with the Air Force under their Cloud One program. Washington Technology reports this is part of the Air Force's broader modernization effort.
Sole source? That's a big chunk of change without competitive bidding. What's driving that decision?
The Air Force seems to be doubling down on their existing AWS infrastructure. This contract covers cloud services and hosting as part of their modernization push. For platform engineers in the defense sector, this signals a long-term commitment to AWS tooling and services.
It also highlights how deeply entrenched cloud providers can become in large organizations. Once you're that invested in a platform, switching becomes almost impossible. That's something every platform team needs to consider when making initial cloud decisions.
That wraps up this week's news. That's our show for today.
If you found this valuable, please subscribe and share with a friend who'd appreciate it.
Drop us a comment with your thoughts on today's topic.
/links to everything we discussed are in the show notes.
And check out platformengineeringplaybook.com for more resources and guides. Until next time.